Welcome back to our series on the Raspberry Pi Pico. So in this video, we're gonna go ahead and work on putting a temperature probe onto this Raspberry Pi Pico that we soldered on the previous video. So some notes from the previous video. First, over here on pin 38, that pin, even though I did check continuity on it, it's one of the ground pins, and when I try to go through it, it's not working correctly. I do need to resolder it, but as of right now, there are several other ground pins, so I am leaving that one off for just now. I don't think it's going to make a difference. That's the only pin I've come across that I've had problems with, and if you can see here on screen, that one does clearly look like it's missing, and that is also one of the pins that I overheated and it melted the plastic of the pin header and actually pushed the pin through. So this is actually a recessed pin, so I'm gonna have to go through and correct that. So other things I've done since that video is that over here on pin 36, I connected that to a common power rail, and then pin 33 is also a ground pin, but it's listed as an A ground. It's for the analog to digital converter. So I'm not sure if I'm going to be doing anything with analog to digital converters in the future. So I'm leaving that pin off, even though from the data sheets, which I'll include links to in the description, it says if you're not doing analog to digital, you can just connect that ground pin to the digital ground. On the data sheet, it also does show all the other grounds to be bonded together, and with the exception of pin 38, that's also what I've done. I've connected all the other ground pins to a common ground. I connected the two power rails and ground rails of the breadboard. I just used any pin headers I have that fit. I have a collection of pre-cut pin headers. So I have those pre-made jumper wires that I've used here. Same thing where it's not a color consistency with the ground wires. And additionally, over here on pin 1, which is connected to IPO 0, is a jumper wire that I put, and I'm using this as a reset or a breakout. So instead of in the while loops, just do while true and making it an endless loop, I'll be using that to check this sensor, and once it goes to check the condition on that while loop, if it's set negative, it will break out. If it's positive, it will keep going. So the sensor that we're going to be using is a DS18B20. It is a single wire connector, meaning that on this sensor, which is connected through this wire, is only one data wire, that yellow wire. So I'm going to turn this board around just so it's easier for me to get to. So what we're gonna do is connect to the first. We're going to take it says to use a 4.7K resistor. I double I think this is about a 5K resistor when I measured it. I have to double check the color code. So this needs to be connected between the VCC, which is the 3.3 rail, and the data pin, which we are going to be using GP16, which is on pin 21, the last pin here. So I am going to go ahead and connect the resistor there to VCC. This is for prototyping. I don't want to cut down my resistors, even though I have bags of resistors. It took me a while to find this one. So I'm going to just leave it wide for now because I don't know what I'm going to be using for future projects. So going to connect the yellow wire here, which is the data wire, into pin 21, GP16. So when we get to the code, all the pin numbers are labeled by their GP pin, and I'll include the breakout of the diagram of the Raspberry Pi Pico, and then I'm going to connect the red wire to the VCC, and we will go from there. Now we'll go ahead and start working on the code for this, and well, this doesn't have any LEDs yet. We'll see about doing some type of output later on, but for right now, we'll get to the code. Okay, so here we are. So we are gonna go and access the Raspberry Pi Pico. I have this script I made for remote, just using the R shell, which I discussed in a previous episode, and I will include the link for that in the description. So I'm going to run remote. It connects to the Raspberry Pi Pico, and if we look in the Pi board, which is the directory on the Raspberry Pi Pico that R shell shows, we see there's a couple files. One is rblink, another one is seg, which we will get to in a previous or in a future episode, and temp.py, which we will go over in this episode. Now I want to make a note of this rblink. This is a file I made for a previous video, and since then I've used reset the Raspberry Pi with the boot select button and reconnecting power. This file has stayed. So resetting it with the boot select allows you to reprogram the Raspberry Pi Pico, but it doesn't clear the memory. So if you do have files, it does save here. I tried looking through the datasheet. I couldn't find a definitive of when and how this clears, but I'm assuming that this is saved on the system on a chip, the Cortex, I think M0 Plus, and not on the RAM chip. I tried to look at the data sheets and the schematic, and I couldn't really be sure, but I do know that I've reset or used the boot select on this several times and was not able to, and this file has stayed. Not that I wanted it to be deleted, but I have I expected it to be. So we're going to run into the, well, first let me go through the temp.py file that I created, or the pyboard slash temp.py file. So first thing is basic header information. I did use this website here, the PyBits, to get some of the information on how to use this sensor. So we're importing the pin function from machine. We are also importing the Wi-Fi, the onewire, the DS18X20 time, and the rest of the machine here. We're going to define some variables here: the start pin, the DS pin, the DS sensor pin, and ROM scan. So I created a couple functions here. The first one is getting the temperature in Celsius. It runs this dsn.convert temperature. It sleeps for 1 second. It could be less. I just decided to leave it at 1 second. And then I am running this print command, and it's running the dsn.read temperature from the data. And then it's printing it out in degrees Celsius and then waiting another 2 seconds. I did a similar function here for temp.f, and this is converting it to degrees Fahrenheit. And then below we have check temp F and check temp C, which just runs through the temperature. Right here, you can see I have it checking every 300 seconds. I'm going to change this to every 60 seconds, just because you don't need to wait 5 minutes while watching this video. And then for the temp C, I don't have it waiting. But this is where you can see where I have the stat pin, which if you look up here, I have as pin 0. This is the pin that I showed earlier that I'm using as essentially a breakout pin. So this will run indefinitely until I switch that pin from high to low. So for right now, the two functions that we are looking at is temp.f and temp.c. So back here to the menu, go to the RPL, and we're going to import temp, and we are going to temp.tempf, and we're going to run that, and it's currently 79 degrees in my office. I have the air conditioner off to hopefully alleviate any noise on this recording, but we're going to run temp.c, and temp.c is 26 degrees, or 26.125. Now, moving forward, we'll be working with some other aspects, but again, we can run temp, hit tab, and these are the functions that we have. So we can run check F, make sure you include the open and close brackets, and hit enter. So now it's going to keep running this indefinitely until we go ahead and reset that. So the first reading was 79 degrees, 0.025. And then probably should have made it more like 30 seconds, but we'll go through and wait for it to register the second iteration. And moving forward, we'll work on some other ways to either record or display this information. Right now, we're using the serial terminal. And from the serial terminal, you'd have to be running and watching it. There's other ways to do that. So now this function has ran a second time. The temperature hasn't changed. So we'll go ahead and connect that pin to low. And the next time it runs through the iteration, it will close. It hit an error right now, probably because the way I moved it. So we'll go back to the menu again, import temp, and then temp dot temp. Let's go with Celsius this time. Whoops. Temp dot temp C. And this one's going to keep running. Oh, correction. Check temp C is the function that should keep running. Okay. Not really sure why this isn't running. This is a prototype board. I may have hit it incorrectly, and I think I realized why it's not running is that I forgot to reset that to high. So we're going to go back to the Ripple, import temp, and then run temp dot check C, and this will keep running. So 26.3 degrees Celsius. If I go ahead and move that pin 0 to the ground, which is equivalent to 0, it's then equates to false. So this is just the basic basic running of this sensor. So we'll go through and what we can do in future episodes. One of these things is that this this function right here, or this process right here, this may be able to this and the DS convert temp, and that can maybe be put into a separate function because we're running it multiple times, and maybe we need it for a process where we just need the raw number. So this is the board connected to the sensor, and in a future video we'll go ahead and connect it to a 8-segment display. And there's be a couple more videos going through it. The next video will be setting up this 8-segment display, which I've been playing with, and then getting everything to work together to display a temperature on that 8-segment display. Other things in the future may be to use this Arduino Uno or some other Arduino processor. I have several I haven't played with yet. I do have some other Raspberry Pi Picos, and then once we get the Raspberry Pi Pico set up, we can go ahead and do other things with it. I do have other sensors, and we can connect other sensors, or what we can do is we can design a breadboard, and with that breadboard we can design a schematic, I should say, and that we can create a PCB and connect everything up. So those are some functions that we can do in the future. In the meantime, if you want to see what else is going to come up, how we can, instead of using Micropython, we can use C or C++ to do this. Go ahead and subscribe. If you want to see the source for this, I will be putting it on the channel's GitHub. You can take a look at that. I will put the version that I have here, and like I said, as I make changes, I will put future versions. Currently I'm on version 0.3, and we'll move on from there. If there's anything you want to see or any suggestions you have, go ahead and comment. If you like the video, hit like. If you don't like the video, hit dislike. That gives me more information on what I should do going further. And either way, if you like or dislike it, tell me why you don't like it or you do like it. This way we can maybe adjust what is being produced, and so you can get better content. In any case, I want to thank you for watching, and I hope that you'll return on future videos, and you have a great day.